Hello everyone, and welcome to my virtual poster presentation. For my presentation, I will be discussing the ontogeny or development of feeding of Tyrannosaurus in collaboration with Doctors Eric Snively, Paul Gignac, and Gregory Erickson. Tyrannosaurus has been viewed as a model organism with studies analyzing its biomechanical feeding behavior. Gignac and Erickson estimated that an adult T-Rex was capable of exerting a bite force of 22,000 to 35,000 newtons at the posterior teeth. While the feeding behavior of adult T-Rex has been thoroughly studied, the same cannot be said for a juvenile T-Rex. Studies have suggested that ontogenetically, Tyrannosaurus underwent dramatic developmental changes where juveniles were incapable of relatively powerful biting as seen in adults and may have engaged in niche partitioning. Juveniles possibly fed on smaller prey, whereas adults fed on larger prey animals, fulfilling different predatory ecological roles. In our study, we used muscle force reconstruction and finite element analysis, or FEA, on the crania of a juvenile and adult T-Rex. This method involving a muscle force reconstruction was analogous to that of Gignac and Erickson 2017, where we mapped the areas of jaw muscle attachments in the crania of the two specimens. Our muscle force results revealed that our adult specimen had much greater force magnitudes because of its larger adductor chamber, slightly inflated because its ectopterygoids do not contact the jugulars. Our FEA results also reveal how the crania responded to high forces upon implementing their individual jaw muscle forces when biting. When placed under high forces, the juvenile T-Rex showed areas of very high stress and strain, in contrast to the adult T-Rex exhibiting low stress at the estimated forces. In the images on the poster, red is an indicator for high stress and light blue is an indicator for low stress. As an example of stress differences at preserved and articulate points on both specimens, the adult had 15% less stress at the nasals and only 1/3 the juvenile stress at the quadratal jugal. Both the muscle forces and FEA results support ontogenetically that a juvenile T-Rex's relatively gracile cranium exhibited high stress when biting, in contrast to an adult's robust skull being capable of handling high forces when biting. This also supports bite forces in tyrannosaurs and alligators increase with positive allometry relative to skull length. I hope everyone enjoyed the presentation, and I look forward to answering your questions. Thank you.